right, this is Ms. Fallon. This is the geometry midterm review packet, and find the page that says similar triangles. Okay, let's see how fast I can do this. Number one, I'm always looking at the given information, and I want to mark that on my diagram. I have some parallel lines on the ends of my bow tie here and here, and what that does for me is it gives me alternate interior angles that are congruent. So angle D is congruent to angle A, and angle C is congruent to angle B. And then I also see, just in the diagram itself, I have some vertical angles. So I now know that all three angles of one triangle are congruent to all three angles of the lower triangle, and now I know that the triangles are similar. So the question says which relationship is true about these two triangles? Well, no, they are not congruent, and if you look at the diagram itself, that's kind of apparent. Yes, they are similar, so I'll circle that and come back to it. Are they equal in area? Well, we haven't really studied area yet, but area is the amount of area that it takes up on the page, and one is smaller than the other. And perimeter is the distance around a figure, and we haven't studied that either. So kind of by just ruling that out, because we haven't studied it. So the correct answer for number one is B. They are similar because of the AA similarity postulate. So scrolling down to number two. Number two, lines JK and RS are parallel. Lines JK and RS are parallel. Good to know. Which of the following statements is true? I think I said this in a lot of the classes, that if you have parallel lines running through a triangle, then I know certain things. Let's see what they're looking for. JR, I'm going to use a highlighter here to see what they're talking about. JR is this segment here, and they're saying that that over this piece, the QJ, is going to be equal to KS over RS? Well, that just does not make any sense. I'm crossing that out. Let me return the diagram back to its normal state so that I can continue going through the process. B, let's look at B. JK is to RS as QK is to SK. Well, that looks good and everything, but what they did is they have two triangles here, the smaller one on top and the larger one as the whole. And they're saying the first part is fine. You take the bottom part of the little triangle, and it does correspond to the bottom part of the big triangle. However, QK, this side, should coordinate to the entire side of the big triangle. But that's not what this one says. It's only using from S to K. So that does not work. Erase my diagram and get ready to try out the next one. The next one says QR is to KS. QR is to KS. Well, we don't have anything, any rules that look like this. But let's see what this is going for. And then they say that Q to S is to R to J. So it's a similar pattern, but I am very suspicious. I'm just going to put a big question mark there. Makes sense, but I'm not sure. Okay, let's go on to the next one. D, QR is to QJ, so the little piece. Okay, so if they're looking at the bigger and the smaller triangle again, they're indicating that these two pieces have a relationship, and I'm okay with that. Let's go on to the other one. QS is to QK. I like it. That's exactly what we've talked about. And it's in the correct order where the top part of the fraction comes from the bigger triangle and the bottom comes from the smaller triangle. And that works. So this is the answer that I want. Moving on. Number 3. Given triangle LMQ similar to LNP. Okay, we've got a triangle and a triangle here again. So I'm going to trace that out. So there's LMQ. And they're telling me that it's similar to the whole large triangle, which is LNP. So let's see what they're wanting us to match up here. They're saying that they're similar triangles, and now they want us to do certain things. All right, so first we're going to see if LM is to MN. Okay, well that's that little piece down here. So they're saying the large, no, this, oh, the piece to piece. Okay, yeah. All right, so far I'm okay with this. So let's see. We have piece to piece. It's kind of a shortcut, but let's see where it goes. And then they say P to Q. Whoa, wait a minute. They put LM in the top, which is the whole. I expected to see this piece in the numerator. I wanted to see that part in the numerator and this part in the denominator, but that's not what happened. They have this in the numerator and that in the denominator, and that just does not work. It's upside down. I cross it off. All right, return it back to normal. So if I have my little one here, I might need that later, so let's bring it back. All right, second one, L to N. L to N, so that's this whole side is to L to M. Okay, so far I like it. We're going from the bigger triangle over the small triangle. So let's see if the next ratio does that as well. N to P, bigger triangle, to M to Q, smaller triangle. Ooh, I like this one a lot. I really do like this one. I'm wondering if this is the answer. Okay, so let's make sure that none of the others make sense. Okay, so if I have my smaller triangle again, L, M, Q, and I have LNP. And by the way, the name of my very first pet cat was Fuzzface. I'm just kind of curious to see who actually watches this video all the way through and learns the name of my first cat. So if you just heard me say that the name of my first cat is Fuzzface, go ahead and write that down on my paper. I might ask you about that later. All right, but going back to this, we have LM. So L to M is the smaller triangle, and it goes to LP. What? They don't coordinate at all. That doesn't make a lick of sense. I am eliminating choice C, because that just didn't make any sense whatsoever. Let's select my squiggle and delete it. Here we go. And let's select this squiggle and delete it, so I don't have to retrace that again. Let's go to choice D. Let's look at L to N. So that's this big triangle to LP. What? It's in the same triangle. That doesn't make any sense either. All right, we're crossing that out. The answer is B. Good to know. Alrighty, number 4. For what value of x are those two triangles similar? Okay. It looks like they're trying to get me to match something up wrong. They've got one triangle sitting on the base of 10, and then the other triangle is a different orientation, and I bet you they're hoping we'll match up things incorrectly. So let's see what happens. Now, oh, here's a big hint. Because they've written our similarity statement, I know that AB has to coordinate with DE. DE is what my X is sitting in. So I know those have to correspond to each other, which means I can put 9 over 2x plus 3, and that's one of my fractions. So right now I'm looking at my similarity statement up here and matching things up. I also know that B to C has to coordinate with E to F. Ooh, that's tricky. I'm not sure I would have put that together just by looking at it. So B to C is 5 and E to F is 4. So let's solve this proportion and see what happens. So if I cross multiply and make the butterfly, oh yeah, I did it. I'm going to come up with the following equation. 5 times the quantity of 2x plus 3 is going to be equal to 9 times 4. So at this point I have to distribute, and I get 10x plus 15 is equal to 36. Subtract 15 from both sides, and I get 10x is equal to 21. And hey, that's kind of nice because I can divide through by 10 and just get 2.1. That's just moving the decimal to the left once. So do I have 2.1 in my answer choices? You know it, sitting right there. Matches my answer choice. Therefore, the answer to this one is B. Number 5. In addition to the information given in the drawing, which statement would be sufficient to prove that ABC is similar to DEF? Wow. Okay, so looking at the answer choices here, A and B are like, what? I'm going to come back to those. What I notice here, with C and D is that they're labeling the other pieces of triangle ABC. And if they label those accordingly, then this might work. So first they're saying, hey, let AC equal 18, so I'll put that up here. And let's let BC equal 8. So, whoa, what? How can 8 be less than, that just looks like a weird triangle. And then they gave us the similarity statement that they're aiming for up here at the top, which means A to C has to coordinate to D to F. So that would put 18 over 4. And let's see, A to B would have to coordinate with D to E. So that's 14 over 7. And if it's going to be similar, they have to reduce the same ratio, which they do not. So C does not work. This makes my brain hurt. Okay. So let's go on to the other one and hope that that one works. I've got AC equal to 8. Okay, that makes a little more sense with my diagram. B to C equal to 18. Okay, so they just switched them for this one. So let's see if this makes more sense. A to C, according to my statement up at the top, has to correspond to D to F. So that would put 8 over 4. Okay, so that simplifies to 2 over 1, so that's kind of cool to know. And we want to know if that's going to be equal to BC, the 18, and BC, according to our similarity statement, has to correspond to EF, which is 9. 18 over 9. Well, yeah, they both reduce to 2. So I like that. So this question was more of which way do I label it? I still don't understand what they were trying to do with A and B, but now that I found an answer that I like, I'm just not going to worry about it. Last page, number 6. Which triangle is similar? Oh, really? Okay, to XYZ. Oh, boy. All right, let's start with choice A. Well, the smallest side in choice A has to, if this is going to work, has to correspond to the smallest side in the big triangle. So we can set up this fraction. The next biggest side has to correspond with the next biggest side. So 20 over 12. And the largest side has to correspond to the largest side of the big, and so that would be 25 over 15. Now, if these all simplify to be the same scale factor, we're in business. So I can simplify top and bottom here by dividing by 2, so that's 5 over 3. So that's what it simplifies to. I can divide top and bottom by 4 here. So that would be 5 over 3. So far, so good. Woohoo! Divide top and bottom by 5 here. And I get 5 over 3. I love it. I circle it. This is the answer. I do a little dance. And I like what I see. So I believe, yep, this concludes the explanation of the sections on similar triangles. I hope that made sense. You can email me at nfallon@spotsylvania.k12.va.us if you have any questions.